section 1.4. I'm gonna do something a little different this time. We're gonna talk about three different cases where a function is not differentiable. Okay, so let's see. So right here, remember in example 5, we looked at a rational function. In that rational function, the function was f of x equals 1 over x. Now, that function is not defined everywhere, right? You cannot have 0 in the bottom of the fraction. So, it says we cannot evaluate f of 0 because f of 0 is 1 over 0 and that is undefined, right? So we can't have f of 0. But if you're trying to find the difference quotient, okay, if you're trying to find the difference quotient at x equals 0, we're going to have to do, hold on, let me go ahead and write it down, because I think we memorize things if you keep on writing it. See, that's the difference quotient, right? Hold on. If x is 0, what will happen is I'm gonna really plug in 0 everywhere I see x, okay? That will be 0, oh whoopsie, that's the highlighter. 0 plus h minus f of 0 all over h, right? But without even going further, take a look. There is f of 0. But didn't we just say f of 0 is undefined? Because we can't have 1 over 0. So because we're missing that puzzle piece, we can't go further. We can't find the difference quotient. We can't even find the slope of a secant line. So because we can't simplify this difference quotient, we won't be able to plug in h equals 0 to find the slope of a tangent line. So here's the first, this was the first example. Let me go in and erase some stuff. I think I was talking about this. Yes, so the difference quotient, if you plug in x equals 0, this f, because this f of 0 is undefined, f prime of 0 does not exist. Okay, so when f prime of x does not exist, what we say is f is not differentiable at that point. Okay, so we're saying the same thing. Slope of a tangent line does not exist. That means this function f is not differentiable at that point. Okay, when a function is not defined at a point, it is not differentiable at that point. Anytime you have like an open circle on a graph, or like if it's a rational function, we're going to have that vertical line, vertical asymptote going up and down. So if you have any of those, the function is not going to be differentiable, okay? Because we won't be able to find the slope of the tangent line. F prime of that number does not exist, okay? In general, okay, here's the first case. If the function is discontinuous at a point, then it is not differentiable at that point. So do write it down. Do write down case number 1, because I said that I told you that we're going to look at 3 different cases, right? If it is discontinuous, then we're going to say it is not differentiable, okay? Okay, so that's the first case. Now let's look at another case, okay? Case number 2. Sometimes the function f is continuous at a point, but f prime still does not exist. I want you to take a look at this absolute value function. This v-shaped function is continuous everywhere. We can graph this function without lifting our pencil. And I mean, we talked about continuity, the definition of that in section 1.2. You see how the left-hand limit and the right-hand limit as they approach x equals 0 is the same. They're going to the same point. And the function value at f of 0 is also 0. So it is continuous everywhere. But what we're going to say is that this function is not continuous at 0, 0. Whoopsie, I used the wrong word, I'm sorry. This function is not differentiable at that point 0, 0. Okay, take a look at this picture for me, okay? If I try to draw a tangent line, okay, I can draw this line, okay? Looks like I'm just gonna make it out, okay? It looks like maybe a line that's going half x, okay? That may be an equation of that line. What is the slope of that line? Slope is 1/3, right? But I can draw another tangent line. Can you see this one? Okay, I may say this equation is like y equals negative 1/4 x, okay? It's going through that origin, but it's going down from left to right, and I'm thinking it looks like negative 1/4. But the exact number doesn't matter. But what I wanted you to pick out is that the slope of that tangent line is negative 1/4. You see how these two highlighted slopes are different, right? There is not a unique tangent line. So we have more than one possible answers. So if that happens, what we're going to say is it's not differentiable. We need to have a unique tangent line. Okay? So, and this will happen anytime you have a corner, like a sharp angled corner. Okay? So what we want is a smooth curve. But anytime you have these angles, we're not going to have a unique tangent line. So let me read these words over here for you. Sometimes function f is continuous at a point, but f prime still does not exist at that point. Okay? We looked at that example, f of x equals absolute value of x, and we had a pointy right here at the origin, and because we had a sharp angle or sharp corner right there, we were able to draw more than one tangent lines, okay? Suppose we try to draw a tangent line at 0, 0. We did that. A function like this with the corner seems to have many tangent lines at that point 0, 0. So what we say is, well, because that happened, the derivative at such point would not be unique. And if this happens, we're going to say f prime of 0 does not exist. In general, a function is not differentiable at any corners on this graph. Okay, so do write this down for me. Number 2, sharp corners. If you have any sharp corners in the graph, it's not going to be differentiable. And some graphs have corners, like absolute value function, right? And we can do piecewise. Well, absolute value is somewhat of a piecewise. Okay, but look at these 3 pictures for that I have copied over here for you. You see the sharp corner right there? We should be able to draw multiple tangents, and that's not good. We should have a unique tangent line. So f prime does not exist. F prime of a does not exist. We can also say that f is not differentiable at a. Okay? All right, another one. Here's a sharp corner right there. And because we can draw more than one tangent line, we are going to say, well, the function name is g. G prime of a does not exist. Okay? Slope of a tangent line at a does not exist. Or simply say g is not differentiable at point a. Okay? Well, this guy has 2 sharp, well, not that sharp, but still angled, right? So we can still draw in some, it's kind of hard, but yeah, I suppose. We can have more than one tangent line at these 2 points. So this graph, the function is named k. K is not differentiable at a's of 1 and a's of 2. Or we can say another way, k prime of a1 does not exist, and k prime of a2 does not exist. So we looked at 2 cases so far. First, if a function is discontinuous, it's not going to be differentiable. Case 2, if it has sharp corners on this graph, it's not going to be differentiable. And here's the last one. Look at this picture for me. If I try to draw a tangent line at this point A, the tangent line happens to be a vertical line. Okay? What is the slope of a vertical line? What is the slope of a vertical line? It is undefined, right? And remember, derivative is its slope of a tangent line. So what we are saying is, if I'm asking, hey, what is S prime of A? I'm asking, hey, what is the slope of a tangent line at A? Well, guess what? Slope of a vertical line is undefined. So S prime of A does not exist. It's undefined because slope of a vertical line, slope of any vertical line is undefined. So case number 3. Okay, case number 3. If you can stick in a vertical tangent, not horizontal though, okay? If you can draw a vertical tangent, then this function is not going to be differentiable at that point, okay? Horizontal tangent is fine because what is the slope of a horizontal line? 0. 0 is a number, so that one's okay. And later we will work a couple more examples where involving a horizontal tangent line, okay? But vertical tangent is because the slope of a vertical line is undefined. Slope of the tangent line does not exist, okay? So we looked at 3 cases. Let's practice them. What's this? Well, I guess at some point when I created this note, I thought that was very useful. But I feel like you guys can read this, and if you have any questions on this part, you let me know. I want to jump into some examples now. All right, example 6. Below is a graph of y equals t of x. It's a fun-looking graph. It says, list all x values for which t is not differentiable. Guys, we divided into like 3 different cases, so I'll do it that way again. I will say case number 1, t is discontinuous. Is that how I spell continuous? Oh, sometimes I have these moments, guys. But I guess it's okay. Okay, if I spelled it wrong, let ignore it. T is discontinuous at, let's see, let's find this graph. So I'm following my graph. Oh, I have to lift my pencil right here. B is discontinuous at B. Keep on going. Oh. Here's an open circle right here, and I have to go down here. I'm discontinuous at C. Keep on following. I see what's going on here. There's a sharp corner, but I'm gonna ignore that for right now because I'm looking for discontinuous points. Right there. I have to jump over here, so this is also discontinuous at F. Let's see. Keep on following to see if I need to lift my pencil anymore. No, that's it. So T is discontinuous at B, C, and F. Therefore, it's going to be not differentiable at those 3 points. Can I just abbreviate just not differentiable, which means slope of a tangent line does not exist at these 3 points. Case number 2 was what? Case number 2 was sharp corner, okay? T has, I'll really just say it, sharp corners at, let's see, do you guys see any sharp corners? I see it at D. This is kind of pointy. Any other places? I see it at I. It's kind of pointy over there. So I'll say T has sharp corners at D and I. Therefore, not differentiable at those 2 points. What was case number 3? T has a vertical tangent at anywhere they graphed a vertical tangent for us. It did over here at J. Because it has a vertical tangent at J, and because vertical line has undefined slope, slope of a tangent line does not exist, which means the function is not differentiable. So we looked at 3 different cases. We looked at an example. I know you're going to see some examples or problems on your homework, so have fun with those. Let's do the very last question, and that will be it for this week's online lecture. Quick check. Where is f of x equals Oh, look at that. Absolute value of x plus 6. This is a horizontal translation. We're going to move 6 to the which direction? Left. Okay? I'm teaching Math 161, so I know what you guys learn already. So if I draw a XY axis, I need to go 1, 2, 3, 4, 5, 6 to the left. And there's no vertical translation. They're not adding or subtracting a number outside. So I know it's going to sit right here, and I will have my beautiful V-shaped graph going up to the right, going up to the left. Now, where is this function not differentiable? Okay, we don't have any discontinuous points. Okay, we don't have any points of discontinuity. We don't have any vertical tangents. But guess what we have right there? We have, well, can I say f has, well, I get to be specific, we should say f's graph has, well, let me just say, hey, sharp corner exists. Sharp corner at what number? X equals -6. So, not differentiable at x equals -6. That's it. And if you wonder why does sharp, what's wrong with it? Hey, remember, because at the sharp corners, we can have multiple tangent lines, and multiple tangent line means we're not going to have a unique tangent line, so we can't discuss the slope of the such line. So that's it. I am done with section 1.4. Thank you for your patience this week, because I know I was a little late on posting these recordings because that technical difficulty. So that's it. Next week, we're going to go over, finally, we're going to do some tricks. We're going to do some shortcuts. So I think you will like next week's lesson a lot. So I will see you guys next Tuesday, okay? All right, I will stop the recording now.